Welcome to the Online classes. In this session, we will discuss NCERT numerical on reflection and refraction of light. Let us see first numerical. Numerical is a small candle 2.5 centimeter in size is placed at 27 centimeter in front of concave mirror of radius of curvature 36 centimeter. At what distance from the mirror should a screen be placed in order to obtain sharp image? Initially we will see this only. Remaining what it is? A small candle 2.5 centimeter in size placed in front of concave mirror at a distance of 27 centimeter in front of concave mirror. We know that a concave mirror sign convention for object distance, image distance, principal focus and focal length of concave mirror all are taken to be negative according to convention. So initially we will see what are given values. Look at me. A small object size O is given. How much? 2.5 centimeter in size. Placed 27 centimeter in front of concave mirror. Mean object distance given, that object distance is equal to minus 27 centimeter of radius of curvature 36 centimeter. Radius of curvature R is equal to minus 36 centimeter. What is given? At what distance from the mirror should a screen placed in order to obtain sharp image? In order to obtain image distance, what distance should be placed a screen from the mirror? That we will see. To solve this, so let us go for mirror formula. What is mirror formula? 1 divided by F is equal to 1 divided by U plus 1 divided by V. We need V here. Then how to solve? 1 divided by V is equal to 1 divided by F minus 1 divided by U. Here U given, I need F value. What has given? R value given. We know relation between radius of curvature and focal length. What it is? F is equal to how much? F is equal to R divided by 2. R is minus 36. Minus 36 by 2. Then F is equal to how much? Minus 18 centimeter. Right. Now, using this value you can solve it. How to obtain? 1 divided by V is equal to 1 divided by F. F is equal to minus 18. Minus of 1 divided by U is equal to minus 27. Minus into minus, this becomes plus. Then from this, what image distance we are getting? V is equal to minus 54 centimeter. Minus 54. Minus mean it is a virtual and inverted image. This image is what? This image inverted and virtual image. Virtual and inverted image. This is half of the problem. Then remaining half of the problem we will see. Describe the nature and size of the image. Describe the nature and size. What nature it is? Negative mean it is a virtual and inverted image. And let us take what is size of image. To obtain size of image, we should go for linear magnification. What is linear magnification? Linear magnification is equal to what? I divided by O is equal to minus V divided by U. In case of what? Mirror. Then again, I is equal to how much? I is equal to minus V divided by U into O value. Size of image we need. Then I is equal to V given. V already we got. Minus into minus plus. That is what value? 54. U minus 27 into 2.5. Right from this. Then from this what you are obtaining? From this I can directly obtain this is of the value minus 5 centimeter. This is size of the image. Size of the image. Then again we will move. See here, describe nature and size of the image. Size of the image this much and nature is virtual. If the candle is moved closer to the mirror, how would be screen have to be moved? I mean, When mirror moving towards the object, how the nature of the image can occur? See here. If this is nothing but object and this is needle. When needle is moving towards mirror or object is moving towards mirror, the size of the image is bigger. If the case object or the mirror moving, object or the needle moving away from the mirror, the size of image is smaller. If the case needle or object moving towards mirror, nature is bigger, image is bigger. If it is moving away from the mirror, then nature of the image is smaller. This is solution of this numerical. Copy it, we will move for next numerical. Look at. Shall I go for next numerical? Look at me. Okay. Next numerical we will see. What it is? A 4.5 centimeter needle is placed 12 centimeter away from convex mirror of focal length 15 centimeter. Give the location of the image and magnification. Location of the image and magnification. Describe what happens as the needle moving further from the mirror. See here. For convex mirror, object distance only taken to be negative and remaining all are taken to be positive according to convention. Remember this. What is given? See here. A 4.5 centimeter needle, size of object given. Let us go for solution. What is given? Object size given, that is 4.5 centimeter. Place 12 centimeter away from convex mirror. Object distance given, that is u. U is equal to how much? Minus 12 centimeter. Of focal length 15 centimeter. F is given. Focal length 15 centimeter. What is asking? Give the location of the image and magnification. Location of the image and magnification. Look at me. How to do? Location of the image is V value and magnification. Magnification we need. Later on this. Okay. Again for convex mirror, let us use mirror formula. What is mirror formula? 1 divided by F is equal to 1 divided by U plus 1 divided by V. Location of the image we will see. 1 divided by V is equal to 1 divided by F minus 1 divided by U. Image. Or else 1 divided by V is equal to 1, F is equal to what value? 15 minus of U is equal to how much? Minus 12, minus into minus, that becomes plus 1 by 12. Then what is here image? Image size or image distance of the order 6.67 centimeter. 6.67 centimeter. This is image distance. Then what he need again? He need magnification. Again we will go for magnification formula. See here, how it is magnification? Magnification M is equal to what value? Size of image divided by size of object divided by is equal to what value? V divided by U minus V divided by U. Or what is size of the image? Size of the image is equal to what value? Minus V divided by U into what value? O. V given how much? I is equal to what value? V. V is 6.67 minus 6.67. U is equal to minus 12 into size of object given how much? 4.5. Then from this what you are obtaining? From this directly I can obtain this high image. Image size is equal to what value? 2.25 centimeter. 2.25 centimeter. This is what? Image size of the, I need magnification. Then what is magnification? From the size of the image divided by size of object, that is what value? I divided by O. I is how much? 2.25. Object distance how much? 4.5. Then from this nearly we are obtaining 0.56 linear magnification. How much? M is equal to of the order 0.56. This is solution of it. Copy it. Let us move for next numerical. Okay, students, let us move next numerical. See here, numerical is a tank is filled with water to a height of 12.5 centimeter. Real depth of the tank is apparent depth of the needle lying at the bottom of the tank is measured by the microscope is found to be 9.4 centimeter. Apparent depth of the tank. What is refractive index of water? Only we will solve up to this. Later we will see. Up to this one we will solve. Look at me. A tank filled with the height of 12.5 centimeter. Real depth given. How much real depth? Real depth of the tank is equal to 12.5 centimeter. The apparent depth of the needle lying at the bottom of the tank is measured to be 9.4 centimeter. Apparent depth given. Apparent depth is equal to how much? 9.4 centimeter. What we need? Refractive index of water. See here. There is relation between refractive index, real depth and apparent depth. What it is? Refractive index of denser medium with respect to rarer medium is equal to real depth divided by apparent depth. Refractive index of water with respect to air. Again, refractive index of water with respect to air, how to write? Refractive index of water with respect to air is equal to real depth divided by apparent depth. Refractive index of air is 1, so that how to write refractive index of water from this? Real depth by apparent depth. Real depth is equal to 12.5, apparent depth is equal to 9.4. Around what value we are getting? 1.33. This is what value? Refractive index of water. Up to here. Then what is the rest of the problem? If water is replaced by liquid of refractive index 1.33 up to same height, by what distance should the microscope have to be moved to focus the needle? Now water replaced by needle, then for that liquid again new apparent depth is available. For new apparent depth, how sharp image can be obtained? By adjusting the microscope. That is the numerical. See here. Now for liquid, how to write? For liquid, shall I write this relation? Refractive index of liquid with respect to air is equal to real depth divided by apparent depth again. This is new apparent depth. New apparent depth. Then what is new apparent depth from this? New apparent depth is equal to real depth divided by refractive index of liquid with respect to air. Liquid is given how much? 1.63. Then what is new apparent depth? New apparent depth. New apparent depth is equal to real depth. How much? Real depth is equal to 12.5. Refractive index of liquid is how much? 1.63. 1.63 we are getting. Then around what value we are getting? Around we are getting, this is what value? 7.67 centimeter. I mean new apparent depth. What is new apparent depth? New apparent depth is equal to 7.67 centimeter. This is new apparent depth. To focus the microscope, we should get sharp image. By what distance? If you take the difference in between initial real depth and final real apparent depth, initial apparent depth and final apparent depth, then we'll get the sharp image to focus the microscope. Look at me. To focus the image again, how microscope should move? Microscope should get to get image. To get image, what we did? We should take difference between initial real depth and initial apparent depth and final apparent depth. What is initial apparent depth? That is 9.64, 7.67. Right. Then what value nearly we are getting? Nearly we are getting of 1.7 centimeter. To get image. To get image, how microscope should move? Microscope should move of 1.7 centimeter. To focus the needle, to focus the image, microscope should move by this distance. This is solution of it. Copy it. Let us move for next numerical. Okay. Shall I move here for next numerical? Okay, students, look at it. Next one, just 9.4, try to solve it. I will go for 9.5. See, a prism is made up of glass of unknown refractive index. Prism made up of glass of unknown refractive index. What is question? A parallel beam of light incident on the face of the prism at angle of minimum deviation measured to be 40 degree. A prism exists of unknown refractive index whose angle of minimum deviation is 40 degree. What is refractive index of material of the prism? What is refractive index of material of the prism? Refracting angle of the prism is 60 degree. Up to will solve. Later will go. Later will go. Up to here will solve. A prism made up of glass of unknown refractive index, parallel beam of light incident on the prism, angle of minimum deviation found to be 40 degree. See here. Shall I go for solution? A prism made up of glass of unknown refractive index of glass with respect to air we need, because prism made up of glass. Angle of minimum deviation for a parallel beam of light is 40 degree. This is for 40 degree. For refracting angle, I mean angle of prism, how much angle of prism is 60 degree. To solve this, let us go for prism formula, refraction through prism. We obtain prism formula in what way? Refractive index of glass with respect to air is equal to how much? Sine of A plus del m. A plus del m whole divided by 2 of sine of A by 2. Okay. Now, refractive index of glass with respect to air is equal to, or else, how to write this? Refractive index of glass with respect to air, sine A, sine of A means 60, del m means 40, whole divided by 2, and sine of 60 by 2. Refractive index of glass I don't know, but for air is this 1. So Na is equal to 1. Then sine 60 plus 40 sine 100 by 2 sine 50. Sine 50 whole divided by sine 30. Whole divided by sine 30. Then what is refractive index of the glass? Around refractive index of the glass is 1.53. Refractive index of the glass is 1.5. This is half of the numerical. Then let us solve rest half of the numerical. Very simple. See here. Prism is placed in water of refractive index 1.33. Predict new angle of minimum deviation for parallel beam of light. Now, this prism it is placed in water. Water has refractive index 1.33. For refractive index 1.33, what is new angle of minimum deviation? That we need. See here. I need what value? I need new angle of minimum deviation if the same prism placed in water. For same angle of prism. See here. For this one, how to write? Refractive index of glass with respect to water we need. Are you following? Then how to write this again formula? Sine of A plus del m dash whole divided by 2. And whole divided by again sine of A by 2. I need this angle. For refractive index of the water is 1.33. Then again how to write this? Refractive index of glass with respect to water is equal to sine of how much? A plus del m dash divided by 2 whole divided by sine of A by 2. Write down this or else. Refractive index of glass is 1.53 whole divided by 1.33 into sine of A by 2. Sine of A by 2 is equal to sine of A plus del m dash divided by 2. Sin A by 2, sin 60 by 2, sin 30. So sin 30 is 0.5. Then how to write? Sin of A plus del m dash, A plus del m dash whole divided by 2 is equal to 1.53 divided by 1.33 into 0.5, because sin 30 is 1 by 2, 1 by 2 is 0.2, or else A plus del m dash whole divided by 2 is equal to sin inverse of 1.53 whole divided by 1.33 into 0.5. So around sin inverse of this value around where again 35 degree. This value how to write? A plus del m dash divided by 2 is equal to 35 degree. Around 35 degree we are getting, or else shall I solve here? Or 35 into 2, that becomes 70. Shall I write directly this value as I can write as 70 degree, or else this A 60, then bring this side. How to write? Del m dash is equal to 70 minus A means 60. Around what value we are getting? Del m dash is equal to 10 degree. New angle of minimum deviation is how much? That is 10 degree. When the glass is placed in water. Stop it. Let us move for next numerical. Okay. Now, let us move next numerical. See here. What is next numerical? A double convex lens is manufactured from a glass. Convex lens is made up of glass of refractive index 1.55 with both faces of same radius of curvature. Both faces of same radius of curvature. What is radius of curvature required if the focal length is found to be 20 cm? Question is like this. Double convex lens made up of the glass with refractive index is found to be 1.55. See here. Refractive index of the glass, how much it is? 1.55. With both faces of same radius of curvature. Same radius of curvature means one is taken to be positive, second is taken to be negative, and that is equal to r, because according to convention, for one spherical surface, radius of curvature taken to be negative, second one taken to be negative, positive. Of focal length, how much focal length is available? Focal length f is equal to given directly 20 centimeter. For 20 centimeter, what is radius of curvature? To solve this, it is a double convex lens. For double convex lens, we should know lens maker's formula. What is lens maker's formula? Lens maker's formula is equal to 1 divided by f is equal to n minus 1 into bracket 1 divided by r1 minus 1 divided by r2. But r1 is equal to minus r2 and r2 is equal to r. So that how to modify this equation again? 1 divided by f is equal to n minus 1 into bracket 1 divided by r plus 1 divided by r. Okay, again you can modify this. 1 divided by f is equal to n minus 1. So LCM is r means that is 2 divided by r. Okay, this r is, what is r value? From this r value to write n minus 1 into 2f, n minus 1 into 2f, or else r is equal to n mean given 1.55 minus 1, 2 into f, given already f is 20, so that r is equal to 0.55 into 40. So r is how much? 22 centimeter. Radius of curvature is found to be 22 centimeter for double convex lens. I mean equal radius of curvature available, both are that is R1 is equal to 22 centimeter, R2 is equal to 22 centimeter. Again copy it. Let us move for last numerical. See, shall I go? A 4.5 centimeter needle placed 12 centimeter away from convex mirror of focal length 15 centimeter. Oh, sorry, this is over. Last one. Sorry, this is numerical. A object of size 3 centimeter. Object of size 3 centimeter placed 14 centimeter in front of concave lens. Concave lens of focal length 21 centimeter. Describe the image produced by lens. And what happens if the object is moving away from the lens? This will see here. For concave lens, object distance only taken to be positive and image distance taken to be negative. Because for concave lens, object is act as a virtual object and image is act as a real. So that, look at it. What he has given? An object of size of object given 3 centimeter. Place 14 centimeter in front of concave lens, that is U is equal to 14 centimeter. Of focal length 21 centimeter. F is equal to 21 centimeter. What in? Describe the image. Describe the image. I need image distance for this. Very simple. See here. To solve this, what it is? Again, directly we should move for lens formula to solve this. Lens formula mean, what is lens formula? 1 divided by F is equal to 1 divided by V minus 1 divided by U. Okay, this because for concave lens, object is act as a virtual, image is act as a real. Object is act as a virtual, image is act as a real. So that 1 divided by V need 1 divided by V is equal to 1 divided by F plus 1 divided by U. Okay, solve this from this. F given, U given, 1 by V is equal to 1 divided by F how much? 21. U how much? 14. Try to solve it. Then around what value we are getting? Nearly around V is equal to 7.5 centimeter. 7.5 centimeter. This is image distance. Then what he has given again? What happens if the object is moving further away from the lens? If object is moving away from the lens, size of the image decrease. If the object is moving towards closer to the lens, then size of the image can increase. Or in case of mirror, in case of lens also same matter. Object is moving away, nature of the image is smaller. Object is moving towards the lens or mirror, nature of the image is bigger. This is solution of it. Remaining solution, try to solve. Thank you.